Okay, continuing on today with our Laplace transform playlist. We have here a second order differential equation. We have y double prime plus 13y prime plus 30y equals 0. And we're given these initial conditions, y at 0 equals 2, y prime at 0 equals 1. And I've also written down these formulas we derived in previous videos for derivatives and just for the Laplace transform of y. Okay, so to get started with this, for my first step, what I want to do is I just want to take the Laplace transform of the whole thing, take the Laplace transform on both sides. And because on the left side we're split up by addition, I can break this out just writing it like we'll have our first term. Our first term will be the Laplace transform of y double prime. Then here I can factor a 13 out and write it as Laplace of y prime. And then this one we'll take a 30 out and we'll write it as Laplace of y. Then on the left side we'll have the Laplace of 0, but the Laplace of 0 is just 0 because we're basically plugging 0 into an integral. And just a reminder what we're trying to do here, we want to ultimately solve for y if we can and get it in terms of t with no derivatives in the expression. But before we do that, what we can do is if we can just solve for this, if we can solve for our Laplace of y, is then if we can get an expression for this, we can then use the inverse and then we'll have our solution for y. So going ahead with this, we have formulas for everything here over to the right, so let's just use that. So for Laplace of the second derivative, we've got this formula here, so we'll write this as s squared big Y of s minus s times y at 0, but that's just 2, so I'll write that in there. And then minus y prime at 0, but that's just 1. And then we're going to have 13 times this stuff here, so we'll have s big Y of s. And then again, our y at 0 is going to be just 2. And this last piece is just going to be 30 big Y of s. Sorry, kind of running out of space. And this is all going to be equal to 0. So to clean this up, what I want to do is I want to factor out my big Y of s to isolate it. And so let's do that. So here we'll bring the big Y in front. Then this is going to give me, here we'll have an s squared. Multiplying this in here, we'll have plus 13s. And then there we'll have just a plus 30. Okay, then let's just write everything else down. So we're going to have here, we're going to have minus 2s. This is going to be a minus 1. Distributing in 13 here, we're going to have minus 26. And then this is all going to be equal to 0. But now this here is going to be just minus 27. So what I can do is if I just add this on both sides, we can basically bring this over to the left and we can rewrite this as big Y of s, all this stuff right here. And then moving this on the left side of the equation, we're going to have 2s plus 27. But now I want to isolate my big Y of s, so I can just divide both sides by this thing. But I think what I'm going to do is actually factor it first. So what I can do is actually I can factor this thing as s plus 10 times s plus 3. And let's just divide by that on both sides. So here we'll divide by the same thing. So this will cancel out here, isolating the big Y of s. And let me just clean it up so we can see what we have. So now we've isolated our big Y, which is just the Laplace transform of y. So what I can do to reverse this is just take the inverse on both sides, right? So we'll just take the inverse here and here. But then this thing here, this is just going to be our y that we want to solve for. So all we need to do now is just do this inverse Laplace transform and we'll be done. But the only tricky thing is if we look at our Laplace transform table, there's nothing that looks quite like this. So what I'm going to do on this is we need to do partial fractions and then we can split this thing up. Okay, so we have here our setup for partial fractions. And so what we'll do is we'll just use the cover-up method on this to solve for these constant values a and b. Now, to start with, what we'll do is we'll look at this s plus 10 here. And what I need to do to make that 0 is just plug in minus 10 here. Now, if we do that, we don't want to divide by 0. We cover that up and plug that in here everywhere else. And then this value is going to be our a value. So we plug minus 10 in up here, we get 27 minus 20. So that's going to give me a 7 here. And then plugging minus 10 in here, minus 10 plus 3 is minus 7. So this whole thing is just going to be minus 1. And then we'll do it again here for s plus 3. This will give me my b value. So if I plug in minus 3 here, that'll make this 0. Cover that up, plug it in everywhere else. And so plugging it into the numerator, minus 3 times 2, minus 6, 27 minus 6. This is going to give me 21 in the numerator here. And then plugging minus 3 in here, 10 minus 3 is just 7. But 21 over 7, that's just 3. So now with what we have here, I can take this and plug it back into our Laplace inverse. And we can actually split it up because we have the plus sign between these. So now we can split this up into 2 inverses. So the first one, I'll use my a value here. So I'm going to write this as minus 1 over s plus 10. And then for the second one, we're just going to have this b value, which is 3. And it's going to be over s plus 3. But for each of these, we can just recall a formula from our Laplace transform table. If we have the Laplace transform of EAT, the Laplace transform of this is just going to be 1 over S minus A. So in this case, our A value is minus 10. And in this case, the A value is minus 3. And the constants, we could bring this up front in each case, but I won't do it for me. I'll just kind of draw an arrow there. So to get our solution doing the inverse on this, we're just kind of going backwards, and we're using this A value. So the first term is going to be pulling the minus 1 out front. We're going to have e to the A, which is minus 10t. And then for the second one, we pull the 3 out front, and we'll have 3 times e to the minus 3t. So again, this is just our y value for this equation. If you took the first and second derivatives and plugged it back in, you should get this same solution 0. And this should be the same solution you get if you were just solving a second order homogeneous equation by the normal methods. Anyway, that's it for today. More Laplace transforms in the next video. Thanks everyone for watching. Have a good day.